look at the most critical issues facing our planet, what do you see? As a bold, unified One Emerson, we see these issues as noble causes, and within each of them, opportunities to focus our core strengths and unleash new possibilities. With our innovative technology, deep expertise, and ability to deliver practical digital transformation solutions, the success of our Automation Solutions platform is providing real results for our customers while still protecting our planet. We see our most valuable resources being put to greater use, ensuring the performance and safety of industries that are the backbone of daily life. From our commercial and residential solutions platform, we will continue to push the boundaries of purpose-driven innovation, identifying new growth opportunities. We see a future where better food quality, sustainable infrastructures, and advanced energy efficiency ensure comfort and health for everyone. As One Emerson, the momentum of our successful transformation into two focused platforms will continue to reshape industries and redefine success for our customers. We will unleash new possibilities for a future of greater productivity and prosperity, and strengthen our customers' belief that when they partner with Emerson, they can always consider it solved.
Hello, everyone. Don Gillis from Emerson. I'm going to be discussing compressor modulation today with you. It's a two-part series. We're going to talk about two-stage, variable, tandems and trios, and also going to get into the digital side of things, okay? So bear with me. Let me take time here to pull my screen up, share it with you. Okay. Again, I'm Don Gillis with Emerson. This is going to be our virtual classroom. We're going to be talking about capacity modulation today, all right? And a little bit about myself. Again, I'm Don. Joined Emerson in July of 2017. Have approximately 28 years of experience, roughly. I've been an installer, a service technician, a service manager. Obviously, I've done some tech support, and I am a full-time HVACR instructor for Emerson. I am a licensed journeyman. I've served on the Heating Advisory Board for Ivy Tech Community College. I now sit on UNOH Heating Advisory, also on High Point in Bellefontaine, Ohio, and so on and so forth. Most of you probably know, if you're instructors, I've spoke at RSES National Conference a couple times, and as we're doing right now, the HVAC educators also I've done a couple times in Vegas, okay? I am a judge at Skills USA National for the last 3 years, and then my credentials of what I've attended and the different schools I went to are at the bottom there, okay? So enough about me. Let's get into our modulation. Learning objectives today are going to be, after completing this session, you'll be able to describe the operation, functionality, and benefits of compressor modulation methods, including two-stage, multiples, digital, and variable speed. And we're going to explain how to perform a scroll or discus digital upgrade, and we've got some videos for you on that also. So capacity modulation. We're going to talk about capacity modulation with scroll compressors. The first thing I want to do, though, I think it's important to understand how a scroll compressor works, actually. Just the, for lack of better terms, the anatomy of the scroll, okay? Most of you might already know this. The students may not, okay? Some of you instructors, if not all of you, probably already know where I'm headed with this, but I think it's important to point out just a few things about the scroll that I think will make better sense when we get into the modulation part, when I start using some terminology, all right? Let's talk about the scroll set itself. So on the left-hand side, we have the orbiting scroll. That's the movement scroll. It's at the bottom. You'll notice these little notches out of there on the scroll set, okay? That's where our Oldham coupling is going to sit in. I've got a couple here for you that I was going to show you also. So here's our orbiting scroll, and here is our fixed scroll, which is on your right, okay? All right, so just so you know, I'm not going to go into all the details about the scroll set because this is about modulation, but I do want you to understand some of the moving parts in here. I think it's important for us to have this conversation prior to getting into modulation, okay? The very top of this is your tips. The sides is your flanks. This is the Oldham coupling, and the Oldham coupling, moving back here, is what keeps this aligned, all right? These notches, all right? And let's say this is the orbiting scroll on these two pegs. This is the fixed scroll on these two pegs. And it basically, not basically, it keeps it from going out of alignment. I'll show you, put this together here a little bit. Okay, so that's how it looks. I've got the Oldham coupling on these scroll sets, and it's going to go in like this, move around, and compress that gas along those flanks on the side. All right. This is what we call radio compliance, and radio compliance is, to me, is just as simple as saying we're horizontal movement, okay, side to side, and what allows it to the scroll set to tolerate if you were to get a liquid droplet, if you will. Okay, there's a piece of Swedish steel right here inside this bushing. It almost looks like the letter D. Okay, and that allows it, as you can tell by the arrows, to move left or right. So it almost acts as a spring, if you will. So it's much more tolerant than, let's say, a reciprocating compressor is. It doesn't mean it will take liquid refrigerant, by no means, but it does help tolerate it quite a bit if in fact it gets inside there. So on the left-hand side, we have axial compliance. Now, axial compliance, and I usually typically ask the class to write this down. This is heavily exaggerated. We're looking more at like 1 millimeter to movement up and down. Axial will be up and down, your vertical movement. This is the radial compliance where I showed you that piece of Swedish steel earlier. This is real important to understand this, and this is why I wanted to talk a little bit about the moving parts and just the basic fixed scroll before we get into modulation. The scroll starts out unloaded, okay? It's a 2-pole motor, runs at 3,500 RPMs, roughly nominal, okay? When it starts to load up, as the gas starts to get in, the contactor pulls in, we have a little bleed port here, and as this starts to pressurize on the scroll, the way this floating seal works, this is a large one on the top of it, and it sits right there on top of that fixed scroll I showed you earlier. The bleed port allows gas to get in that cavity. This is normally sitting on that ledge there. And what happens is 2 things are going on there. It pressurizes that cavity, causing this floating seal to push up on the muffler cap, but it also allows the fixed scroll to go down with the tips of those scrolls touching, okay? That pressurizes that and pushes that 1 millimeter. It's important to know that 1 millimeter because, again, that's going to come into play in our modulation. This is just a better look at the floating seal. Here you're looking at the left-hand side, you're looking at the floating seal setting down inside that fixed scroll. Right down, looking at the top of it. Here's what that floating seal looks like. This plays an important part because it separates that gas, as we talked about earlier. When this pushes up to that muffler plate, it doesn't allow that discharge gas to go over the top of it, so it isolates it, forcing it to go out the top above that muffler plate and at the top of the scroll compressor. If this were to fall down, and I'll get into that later on, okay, this gas would then come around and re-enter that suction gas. Over here is what we call sleeve guides on the right-hand side. That is allowing that 1 millimeter separation when we load and unload, when we get into digital. When I refer to that 1 millimeter on that sleeve guides, this is what I'm talking about, all right? And we'll get more into that as we move along. This is just showing you a check valve. Most all compressors or scroll compressors have check valves in them. They range from anything from inside the discharge line as it moves out, leaving the compressor, to in dead center, right in the heart of the compressor at the hottest point of the compressor in the discharge port. Some may have 2. All right, let's start in with the capacity modulation. We're going to talk about 4 specific modulations. We're going to talk about 2-stage. We're going to talk about variable. We're going to talk about digital. And then we're going to talk about multiples, tandems, and trios. All right. So let's walk through these here. So capacity control modulation methods, and we'll walk through each one of these. Two-stage, just a 30,000-foot view here at the beginning, is full capacity. Obviously, is 100%. It is like a fixed scroll, if you will. That will be your second stage at 100%. Obviously, 67% or 65%. 2/3 of the capacity will be your first stage, and I'll show you how that works also. And then staying at the top to the right of that, we have variable speed, customized scroll with variable speed frequency drives. And we'll talk about the drives and how that works, and because that's the one that's really catching on a lot in the industry right now. And I foresee that being a big major player as it did with mini splits years ago. And then we have at the bottom left, we have digital, mostly seen in refrigeration, can be used in air conditioning too. I don't want to sell it short, but we'll talk about where that best fits at. It starts at 10% to 100%. So in other words, until it gets a call for 10% of the capacity, it does not turn on. All right. And then we have multiple tandems or trios. It's a step capacity, infinite capacity steps, fixed and digital. So you can have the two compressors. They don't have to be the same size. They don't even have to be the same model of the compressors. They can be different BTUs and different tonnage. So we'll walk through those. Now, this is just a snapshot of the compressor modulation technology comparisons. I'm not going to spend a lot of time on this because this is more salesy marketing. I do show this in class, but it's just really to give technicians an idea if they're quoting equipment, what that might look like to them. All right. So we have our fixed scroll. We talked about that a little while ago, just basically the anatomy pieces of it. We have the modulation technology on the top left, and then we have our products, the range, what horsepower they come to, the part load efficiency, full load efficiency, and then what does that look like with comfort? And then we have our applied cost. So again, we start out with fixed. We then have two-stage. We have digital from 10 to 100%, variable speed, and multiples. Now, none of these compressors, with the exception of variable, have a pump for lubrication inside them. All right. So that's unique to that. If you're teaching scrolls, at least the Emerson scrolls, we do our lubrication basically by physics. We manipulate the shaft and different things in there and apply that lubrication up through that shaft by simply just ramping up that 3,500 RPMs that a fixed scroll has. All right. Only exception to that will be our variable speed. It does have a pump in it. And you can see where variable speed shines. On a partial load, it's at its best. Okay. It's the highest of everything. At full load capacity, it's medium. Doesn't do as well. And then for comfort, obviously it's off the charts. The next one that I really think is a great technology, especially in refrigeration and air conditioning, that's catching on quite quickly is the digital. We unload and load that compressor. We don't shut it off necessarily. And I'll talk a little bit more about that here in a little bit. All right, the first thing we're going to talk about is our two-stage. And again, we're talking about 67, 65%. And the reason I say 67, 65, on some videos that Emerson's made, it will say 67%. Some presentations I've seen will say 65%. Neither one of them's wrong. Just remember this, first stage on a two-stage compressor, at least when we talk about it, is going to be about 2/3 capacity. So the 100% is like a fixed capacity. Partial capacity or first stage is going to be about 2/3 of 100%. All right. So Copeland scroll two-stage, you can see how this is working. It's a module if you will. Mechanically unloading compressor operates at 67% to 100%. It utilizes a three-way solenoid valve to pressurize the lift ring. In fact, I'm going to show you, this is part of that ring I was talking about at the very top. And I don't know if you can see this or not. I'll do this again. I attempted this earlier and it seemed to be okay. You can't really tell, but there's three little holes in this, the top of the fixed scroll. There you go. You can see my light coming through there. There's three little bleeder holes on both sides. And they're in the medium area of that fixed scroll. See my flashlight shining through there? Two little bleeder holes. So when those, at the very top, you can see it. When those get blocked off, it doesn't allow that refrigerant to come out, all right, when it slips out, that module. So it's AC to DC, and it causes it to turn and bleeds off. Now in this animation, you can see, now we're powered, we're shutting it off, we're running 100% capacity, all right, unloaded, shutting off, okay. Now, high part load efficiency with minimal full load efficiency losses offers improved temperature and humidity control and 2 to 10 horsepower range. Ideal for 14 and above SEER, residential and light commercial split and package systems. See a lot of two-stage out there in residential and light commercial. And for the most part, I haven't been gone all that long in the field. Two-stage is, I mean, most of the technicians are fairly familiar with it. Do they know how to troubleshoot it? That might be a different story. I don't know, but they understand the concept of it. Now, the Copeland Scroll two-stage modulation operation, at the very top, I'll start up here. Again, you're powered up, all right? Now we're blocked off. We're at 100%, or here we're at partial. We energized, blocking it off. Now we're at full capacity. Here we're at 67%. You can see it's bleeding off. Over here on the right, partial load operation, intermediate cavity, pressure communicated to a lift chamber via a three-way valve. Valve is de-energized when we go into that first stage, as we talked about earlier. Okay, you can see that lifting up, that lift ring, that three-way, lifts it up, and those bleed ports that I showed you earlier in that medium cavity, okay, here's the low, medium, and high pressure cavities, will bleed out from both sides, all right? Modulation ring moves up, opening the bypass. At the bottom, you'll see it's a full load operation, suction pressure communicated to the lift chamber. The valve is energized now at full capacity, all right? The valve is energized at 100% or a fixed capacity, all right? You can see the bleed ports down here at the bottom on the left. Partial load, when it shifts, those open up. You can see at full load, those ports, if you will, are blocked off. Here's our module. Okay, now we're going to talk about multiples. That's going to be tandems and trios. All right, so all we're doing is taking multiple compressors, mix and matching them. They could be uneven or even. In other words, they could be the same capacity on both compressors, or the trios, the tris, could be the same capacity, the same BTUs, horsepowers, or they could be mix and match. They could have a digital on them. So there's all different opportunities here to best fit that application. So let's take a look at this. This one is the easiest one to comprehend, because all you're really doing is matching up the load with multiple compressors. What is a multiple? It's a pairing of two tandems or three trios, fixed speed and or mechanically modulated scroll compressors, variable speed, digital two-stage compressors, to achieve a capacity modulation. Multiples allow modulation of compression capacity while maintaining efficiency and potential reduction cost. and you see a lot of this in the commercial applications, some refrigeration applications. So very good stuff. Won't see things like this in residential, obviously, but there is a place for it, and we sell a lot of these. The only thing I want to point out to you, if you're an instructor and you're planning on teaching this, or at least touching on it, the thing I like to drive home when I'm delivering this out on the road is be aware that there's going to be multiple model numbers. So each compressor is going to have a model number, and the sled or the trio or the twins will have a model number themselves. So either the tandem and the trios will have a model number, and that's crucial when you're ordering that to get them the right model number, okay? And I'm going to show you a chart later on that you can find in your AE bulletins that's going to decide whether you need to change the whole tandem out or just one compressor. There may not be a service compressor for that tandem or trio, but we'll talk about that on the very last slide. Okay, advantages of compressor multiples: efficiency and economical, high system efficiency at both full load and partial load, possible reduction of applied cost through reduction in number of circuits in the HVAC-R system. Flexibility, it's versatile compressor combinations to meet targeted part load efficiency points. And oil management, no auxiliary oil management hardware needed. And load matching, as they all are in modulation. That's basically the whole concept of matching the load. Stepped capacity modulation for higher part load efficiency levels. You know, we talk about two-stage. The nice thing about two-stage, where it's a good fit, is you do not need any type of special third-party control of any sort. You need simply a two-stage thermostat and you're good to go. So that's one of the benefits in that application. Scroll compressor multiples development and qualification. First, we design them. We oil balance test them. We strain gauge, testing them, and reliability testing. So what does that mean to you? The contents on the design: manifold layouts, analytical studies, FEA, cost or assessment. The oil balance testing, we lab test them. We design verification, performance studies, all kinds of testing go into that, whether it be sound, durability. They have a shake table, strain gauge testing, lab study for the tube stresses. What I was just talking about, they call it a table stand. They'll put it on there and simulate that it's driving down the highway on a semi. Reliability testing, life testing, a final design. You may or may not already know this, but we test all of our compressors, no matter what the model is or type of compressor, to last at least 15 years minimum. That's thinking that you're keeping them inside the envelope, okay? So if you've got a matted condenser coil for 2 years or a whole summer and it's running at high head pressure, that's not going to necessarily be in that envelope, correct? So, but we shoot for 15 years minimum on all our compressors. So this is the older concept. It's called the four-pipe system, the tandem compressor configurations. It's with the oil equalization line, or the OEL, plus gas equalization line. We've got the discharge manifold, suction manifold, the mounting kit, the gas equalization line, supplementary component to further balance pressure differential at the low side of the compressor. And then we have the oil equalization line. Okay, primary ways to balance pressure differential at the low side of the compressors. Now look what we've done here. We went into the multiple configurations and parts added to the compressor with a two-phase tandem. Here we have a two-phase tandem, unlike the four-pipe, and the two-phase tube, or the TPTL, secondary way to balance pressures differential at the low side of the compressors, and it connects the sight glass of the compressors, okay? And then we still have the discharge side up here. Of course, we'll have the mounting kit and the suction manifold. Again, if you are in a position where you change out one of these compressors, if that service ticket allows you to, and not have to change out the whole tandem, be very aware that there's a lot of engineering that goes into this connection between these two compressors. I would suggest not to try to fabricate that yourself. The reason being is sound. This is an actual part itself that you can order along with that. So when you're ordering through the wholesaler, make sure you're aware of that. I'm talking to you like you're a contractor now, because that's the way I normally teach, but you're an instructor. All of you are teachers, but you get the gist of it. Be very, very aware of that. This is for your own personal knowledge. Here's that application engineer's bulletin I was telling you about, the guidelines and bulletins for the compressors. This just shows you the size of the compressor, 5 to 10, 9 to 15, 20 to 40 horsepower. Here's the AE bulletin for each one of them, okay? These are the model numbers, the ranges. This is the compressor model numbers. By the way, this is the tandem model numbers. So this is the model number actually on the whole sled, and these are the individual compressors. Over here, where you see the red check marks, for that particular model and that application, you have to replace that whole tandem on that one, okay? The reason in the comment area is there's no tandem-ready service compressors. So you can't do a 1Z, 2Z, or a 1Z, on that. You have to change out the whole tandem, unfortunately. On the other hand, these other two applications, the 9 to 15 and the 20 to 40, you can change out either. The larger check mark indicates what we'd rather you do, okay? But you have to make that call. If it was a bad burnout and you feel safer that you think the tandem needs to be changed out as a whole, you need to have that conversation with the store owner or the building owner, because that's going to be an added cost, okay? So you're going to have to treat that however you see fit. Well, everyone, that's it for part one of the modulation from Emerson. I'm Don Gillis, and I'll see you on part two the next time, okay? Hopefully you got something out of this. Be safe out there, everyone. Talk to you soon. Bye.